Hi there. How are you this morning? Um, in this video lesson, I'm trying to go over some of my video, some of my tutorial questions related to Proteus, related to the Arduino. I'd like to show you. It seems like my pen is trying to mess me up. I guess it's not hooked up, right? So let's just we'll hook up the pen so that we explain some of the details about some examples, tutorial questions. And these are some of the questions that we may have that are very critical. It's just some questions like that. Some question like that. For example, here's an example of a tutorial question, and some of these questions have been there in some of my past papers. So you assume this is an Arduino, and then you have these pins: pin 2, pin 3, pin 4, pin 5, pin 6, and then pin 7. So we have 2, 3, 4, 5, 6, 7. So you've got these pins, and then these pins, on each and every one of those pins, we have LEDs connected, right? So I have an LED that is connected to, this is the ground. We have another LED that is connected, and this is the ground. We have another LED connected, and then this is the ground. We have another LED connected, and this is the ground. We have another LED connected, and this is the ground. Then we have another LED connected, and then this is the ground. Okay, so now we have got, these are LEDs, the light emitting diodes. Oh, sorry, the arrow should be pointing downwards. So now these diodes, so now we're supposed to write a program such that the LED should light one after the other. So for example, if LED that is connected to pin 2 lights up, it should light up for about 65 milliseconds, and then after 65 milliseconds, LED 3 should come on. When LED 3 comes on, LED 2 should be off. So it should be in a chasing fashion. So this one is on, stays for 65 milliseconds, and this one is off, and this one comes on, then this one is off, and one is on, stays for 65 minutes, and this one is off, just like that. And then when it reaches the final here, it should have a chasing effect. It should go back to the first one, and they should repeat in a cycle. So now the approach to this kind of a question is very easy, and again it hinges around your understanding of the arrays and the for loop, which is a concept that I've taught several times in class. And I just want to show you how we can apply arrays and for loops to this sort of a question setup. Now we know that the Arduino defaults to the space on top, then there's the void setup and the void loop. So basically what we shall do, we shall declare an array. I'll call it int late pins, and I'll give it the number of pins that are there. So we have, this is an array. So let's just go maybe to the next page, because this seems to be crowded. We can go to a new page. All pages, yeah. Okay, so let's just go to the new page. So now that you've understood, so the first thing we need to do is to write the code. And so the way we do it, we're going to first declare an array variable, and I'll call it lead pins. And every time you put square brackets, it means this is an array. And this array, it's going to be made up of the pins 3, 4, 5, 6, and 7, right? Because these are the pins, the LED pins that we have. So because it's a statement, so I'm terminating with a semicolon. Now, so having declared this array, we could now go into the void setup. So in the void setup, this is where we initialize, okay, as we all know. So I'm gonna put that, and I'm gonna put maybe somewhere here. I'm gonna close. So what we need to do, so we look at this. Now we're going to try to, now after initializing this array, we're going to set these pins either as output. Now it's not difficult to see that from this, it's not difficult to see that these are all output ports. And therefore, using the concept of arrays, we can loop through these pins, and then we can declare them as output pins. Now, they're about 1, 2, 3, 4, 5, 6, but counting starts from 0. So this is array number 0, number 1, number 2, number 3, number 4, number 5. So for me to do this, I'm going to loop through them. So I'll use a for loop. I'll say for int x. I'll just declare variable x equals 0, and then I'll say x less than 6, because I have to, because I'm starting from 0. For x less than 6, comma x plus plus. So I'm incrementing the counter, and then I'm saying, what do I want to do for this? Okay, now why 6? Well, you see we start counting from 0. They are total in 6, but then if you have to loop through the array, if you start from 0, then definitely you're saying starting from x and then x less than 6, because the total is 6, because then you're going to have 0 to 5. Can you have this condition for looping? So what is it that we want? So we're going to say that we're going now to have pin mode. We're going to say the pin mode of the lead pins, where we're taking the variable x, comma, output. Output. So we're saying that in this manner, this is an output port. All right, we could actually also initialize, we can say that digital, right? Lead pins. Let me worship the Lord. We can say we initialize them as low. In our words, for x equals 0. So how does this work? So in a void setup, we've initialized these pins, we've initialized them as 0. So what we do now, we're going to say int x equals 0, x less than 6. So let's go through this. So the for loop, what is the function of the for loop? The function of the for loop is to repeat a certain section of code a specific number of times, right? So in this case, this code will be repeated 6 times, but starting from 0. Oh, it's interesting, right? So it will repeat for 0. So the first thing it does, it says int x equals 0, x less than. So we initialize x as 0. Now we say, is 0 less than 6? Yes, it is. Then we pass the 0 into this component, and we make that 0 output, that 0 as an output. Now we pass a 0. Now every time you're passing a 0 here, you're passing an index. Now the content of that index is pin 2. Now that pin 2 in that case, because now the index is a pointer to the pin, it will be, that pin will be treated as an output. In this case, pin 2 will be treated as an output. And then that same one is also going to, the 0 is also going to be here, and that pin 2 also be initialized as low. Then once these statements are run, then it goes back and it increment x by 1. It increments 0 plus 1, which is 1. Again, 1 will be tested if it's less than 6, and then it will be passed on the parameter until all of them have been initialized. This is nice. So now, let's just go to the next page for the continuation. So now for the continuation, now we need to go into now the void loop. Since we've already initialized all of them. So in the void loop, what are we saying? In this void loop, we're supposed to write now the logic to the code. Now what's the logic? It should have a chasing effect, back and forth every 65 milliseconds. So what we do is that we initialize yet another for loop. We shall say for int x equals 0, comma, x less than 6, comma, x plus plus. What do we want? This is the condition for looping. We want that we digital write, right? Lead pins, digital write lead pins, lead pins x, comma what? High. And then we want to delay. What are we delaying by? We're delaying by 65 milliseconds, so we delay by 65 milliseconds. And then once we delay by 65 milliseconds, then we again want to digital write lead pins x low. So we also want to digital write lead pins low. So now we can see here that the way it works is that first of all, the 0 will be passed to this, it will be high, then a delay of 5 milliseconds will take place, then the 0 will be low. And then the looping will start again, 1 will be 1 high, and then 5 milliseconds delay, and then after 5 milliseconds, they need to be switched off. So that will be now the going forward. Meaning that starting from pin 2 to pin 7, they'll be switched on and off in that fashion. Now here is the point. Now guys, this is within the void loop, so let's just maybe make sure that we squeeze everything so that there's logic flow of ideas. Now here we really close it here. Okay, now we'll be switching one after the other from pin 2 to pin 7. Now what about starting from pin 7 going back to pin 2, because that's also, it has to be in a chasing fashion. How do we do that? So we're going to say now, we're going to write another looping here condition. We're going to say for, once this is done, we're going to say for, now we say int x equals, now here we're starting with 5. Remember that index number 5 is actually pin 7. So we're saying for int x equals 5, comma that, x greater than 0. So starting from x, for as long as starting from x equals 5, for as long as x is greater than 0, again I'm making comment, then you should be decrementing x. That's what this means. This is the condition. I start x with 5, and then x greater than, the condition is that for as long as x is greater than 0, I should continue decrementing. So what does this mean? It actually means that when we get, for as long as x is greater than 0, but x starting from 5, we should decrement. So what are we doing here? We again write the same coding. All right? So what are we saying? We are saying we're saying in here, we're still going to do our what? We're going to show our digital, right? Right. So we're going to say LED pins. Now, what about the LED pins? So digital write LED pins, we say digital write LED pins X, right? Comma, what? We can start with high because now we are on pin 5. So the pin 5 will be the one initialized here, and it will start as high. Then we shall delay about 65 milliseconds or further. Thank you. Then we shall also now make it low. Now that's it, guys. This is how you write a code, a possible example of some kind where you have the several LED pins like this, and these will have to be switching back and forth with a delay of 65 milliseconds. Now you can see here what have we done. Just to walk through it real quickly, what we've done, we have first of all declared the pins, LED pins, in form of an array. And this array, at array number 0, index 0, there'll be 2, there'll be 3, 4, just like that. And then we've done a for loop, and that for loop starting from 0, x less than 6, x plus plus, we're saying the pin mode number 0, pin mode number 5, they'll be written as output, and then there'll be also these ones, they'll be initialized as they are output pins, but the starting point is that they are all in low mode, meaning that they don't have a signal. All right, have 0 on the signal. And then here we look at looping issues. This is where we say that for int x equals x less than, we're making this one as high, as 0 is high, we're delaying, and then we're switching it off before we loop through to the other one. Now when this condition is made for about 6 times, because it's for 0, for 1, for 2, for 3, for 4, for 5, for 6, and for 0, 1, 2, 3, 4, 5. And once it's done, it's going to be cast into another for loop. And this is another for loop where now we're not starting from 0, but we're starting from 5. We're saying if int x is equal to 5, we make it high, we delay, and then once we delay, we going to make sure that that same LED pins is again initialized as low, and then it loops back to check on the condition. So also it loops back. When it loops back, this 5 that had started will no longer be 5. Now it will be subtracted by 1, so it will be 4. So again, it will check if 4 is greater than 0. If it is, the 4 index is going to be passed, and whatever pin that is under index number 4 will be the one that will be in the effect. Okay, guys, this is very easy stuff right here. And so what we can do, our proposal, we just try to visualize the simulation, and let's see how this one works. Now I wrote the code so that you see me type. So I had to write the code, and then I think I have the code. It's LED pins array. Okay, so let's just try to check this LED pins array, and then we try to go through the code. And not only that, in Arduino, I just try to show you how it looks like in the compiler. And then from there, we can go to another example, which we can as well look at. Okay, so I'm trying to open this file. It's the Arduino file. Okay, and maybe as it is opening, let's try to open Proteus as well. Proteus file, so that again you don't watch me. Also, you don't watch me set it up. But of course, the setup has already been done. So all we need is just to visualize what's going on. And then this is very cheap stuff right here. It's not difficult. You know you can handle this. Yeah, examples like this are not hard to get. Since okay, this is something else. Okay, so oh, oh, okay. All right, so now I'm putting a potentiometer here. I was also testing for a potentiometer. It appears that this schematic is the same as the one that I put on. However, it's no big deal right here. So what we'll do, we just stop this simulation, right? So what we need to do, I have put my I'll put my hex file here. Don't worry about what I have attached here. So this is my hex file, just to help you visualize. I don't know why. It's just okay. So I have my hex file. I want this folder to open. So this is I can't believe that my hex file has been replaced with. But in any case, the one for the analog input, I'll just also show you. The code is there, but let me just help you understand this. I also get to the ones with the. It appears that when I was saving, I didn't emphasize on saving them into the two different files. So it's like they have replaced each other. However, what we're really doing, and I'll go ahead quickly to explain the same code. It's just one and the same code, except that I've attached the potentiometer. The basic code is actually the same, so I'll go through it as well just to help you understand. However, the code that I just wrote pretty much works. And this one that I've attached, the potentiometer, is one of those examples that I give you where you've attached a potentiometer and then the delay that is coming from the values that we get from the potentiometer. How do we treat that? However, the basic code with the 65 millisecond delay is pretty much the same, except that here I would like to just maybe toggle a bit and I'll go over through this code as well. But this same, I'll show you that they're actually pretty much the same code. So right now what we have running is pretty much almost the same type of, you can see here that the LEDs are actually toggling, but in this case they are toggling based on the values that we get from the potentiometer. But you can see here it's pretty much the same code, except that I had to add an extra code for the potentiometer. But what I wrote works with a fixed 65 millisecond. We can see here, but with this one, you can see, for example, that as you try to toggle this, you can see here, you can watch that as we go up, it may be slowing down because I'm increasing the timing. It may be slowing down in terms of the delay is becoming bigger and bigger as we go up. You can see. Okay, now actually if we go down a little bit, if we go very much down, I'm having a very short delay. I want to expect it to run a little bit faster. Let's just see here. Because as you go down the delay, the potentiometer value that is being given is very small. So here I expect it to have a bigger value, a bigger digital val. So the delay should not take that much. Now, to just show you that it really works as expected, what if we have a zero delay, 0 millisecond? What's going to happen? I expect it to get confused. I expect it to show, for example, I've gone completely low. Look at what is going to happen once it finishes its path. So it's here, it will shift, it goes. Right now it has not completed the first one. You see what's going to happen when it reaches here. Now it's reading another value. You see what's going to happen. Wait a second. Okay, so it's doing it perhaps for the last time. Let's see what happens if we confuse it. We put the delay to be 0 milliseconds. What's happening? I expect it to go basic. Okay, now I see. So what the code, hold on. It's not going basic actually, guys. And I understand the reason why. I've mixed up the coding. Actually, this is a code for 65 milliseconds. But I'll show you now the code for the interactive. This is a code for 65 milliseconds, but it was saved as something else. I think the code for, let me show you now the code for, let me show you the code for with the potentiometer, how it behaves. It's here. Lead pins with a potentiometer. Okay. This is a code with a potentiometer. Let's see what happens. So I can see here that at zero delay, we have this one messing up because now there's no delay. They're almost lighting up. But notice if I start increasing the delay, what's going to happen? For example, I'm increasing everything, it becomes normal. If I provide zero delay, you see when it comes back, it goes back because it's doing the follow for the last time. So when it comes back to initialize, it messes up. So this is the code with not 65 milliseconds delay, but whatever is the delay is coming from the analog val that we'll put. And I'll show you the code, this code. They are just pretty much the same. The one that I was showing you was the one for 65 milliseconds delay. And that's the one that I just wrote. But to show you how the code looks like for the let's first get, before I show you this, let's get the code for 65 milliseconds delay. So we're going to stop this. I show you in Arduino. This is the one that has been trying to open. Late pins array, I called it. It was taking forever to open. Why? Come on, Dad. Excuse me. So I actually wrote two codes. One with the 5 milliseconds delay, another one with a potentiometer. So there was a mix-up in the coding, but I'm just trying to open the one with the 5 milliseconds delay. It is taking almost forever. Okay guys, let me just also now, as it is opening, the one with the potentiometer should not be confusing because it's the same. They're almost similar with the one with the 65 milliseconds delay, except that the one with the potentiometer is an interactive one. Okay, so meaning that we can decide how fast we want the converter. So if we had so for example here, these are digital pins. So what we did, the one with the potentiometer, this is an analog port A0. So in this analog port A0, what we've just simply done is we've connected a potentiometer here, and this potentiometer is the one that we are changing based on the value that we are getting from the potentiometer. We are using it as a delay function to delay the turning on and off of this. So now this becomes interactive, meaning now I'm changing time. I can change to 65 milliseconds. I can change to a higher value. Now remember that the ADC in Arduino is a 10 bits ADC, meaning that you can have up to about 1024 digital values that you could use to help in the delay function. So whatever digital value that you get could be used as the delay function for these LEDs, and that's exactly what that code is trying to do. So, but then the code is just an extension from the 5 milliseconds delay code. So if I go to the code with a potentiometer, because this other code is taking a bit of some time, I'll also show you because I've already given you as an example, and I was trying to explain the coding. So I'll just show you the one with the potentiometer and how to go about it. So basically what it is here, as you can see, the first thing we do is to declare an array, and this array it's called late pins, and it's going to have pins 2 to about 7, as you can see. And I went ahead to declare extra variables, and I called them float. And the reason why you want to call them float is because you know that sometimes this delay can have decimal values. You just want to make sure that you're able to capture those decimal values as well. But if you check the void setup where we initialize, we can see that this is pretty much the legacy code that we've been looking at. And you can see that the ITX equals 0, XX, and then we're doing pretty much what I was just explaining on the notepad. And So the void setup, so this is where now we're saying you code, can you initialize the LED pins as low, but also make sure that they are all output pins. But can you run this section of code almost like 6 times, because you're starting from index number 0 to about index number 5, right? That's exactly what we're doing. And if we go down again, you can see for yourselves that the void loop, which is yet another function, which, so what have we done in the void loop? So what we've essentially done is that we're looking at the analog pin number 0, right? This analog pin number 0, we are reading the analog, we're using the analog read command to read from the A0. But then I know that what we're reading is actually a digital value, which we call it a digital val. Remember, when you read from an analog port, you're not reading the analog voltage itself. You are reading a converted value. The voltage, if 2.5 presented itself on an analog port, then you're reading about 512 if you read. Now that 512 is going to be digital val. So we're saying our digital val is equal to analog read from port A. And this is exactly what we're doing. Now from here now, what are we saying? We are going to go with, again, the for loop. We're saying for int x equals 0, x less than this, for this loop here, right here, please make this LED pin. So you're saying digital write LED pins, if x is 0, you make it high, but then you are delaying digital val. In other words, whatever we are getting has digital value, that's the parameter that we are passing in the delay function. So now that is going to be dynamic, because every time we'll be reading from the potentiometer, so those values are the ones. So we're getting it as our delay. So let's assume that the first index here is 0. So we're going to have 0, meaning that it's talking to pin 2. So we're going to say digital write let pin 0 high, delay digital val, digital what? V. So if we say delay digital val, we're saying if, let's say for example, at one particular point, we are reading now, we've read, let's say 512, right? So it means that we're delaying for 512 milliseconds, and then we are switching again at low after 512 milliseconds, and then delay again like that. Now you understand what's going on. And then now for switching back from pin 7 to pin 1 to pin 0 to pin 2, sorry, we are again using this for loop function, just like in a fixed 65 milliseconds. We're saying, okay, so now x is starting at 5, but x, the condition is that x should be greater than 0, and we should continue decrementing x. So we start with 5, make it high, we delay for that digital val, and then we say digital write let pins 5 low, we make it again low, and then when we do it, we make it again, we delay for that digital val. So you can see here, this is pretty much something that you know, this is a legacy code, this is very easy guys, this is cheap stuff, but that's exactly how we are actually managing these delays. Okay, so for now, I'd like you to go through this, and I think I've already shown you the simulation right here. You've actually seen my simulations. We see that this is exactly what's now happening. Right now, I am at a 0 delay. I'm at a 0 delay. So if I close this and I want to run this, I have a 0 right now. It's a 0. You can see it's messing itself up. But then now, as I am increasing, because the potentiometer now is from 0 to 5 volts. Now 0 to 5 volts could be values that could be sent into the analog port could be at one point, maybe be 2.5 volts is sent on this analog port. So we can have a scenario in which what is being taken in is about 2.5 volts is being taken in, and as it is taken in, it's converted to its digital value equivalent, and that digital value equivalent is passed as a delay. So right now, why is it dancing like this? Well, it's dancing like this because now there is no delay. There's actually a 0 milliseconds delay, because you can see here that it's at its lowest. The potentiometer is at a lowest point right here. You can see it's at the lowest point right here. But if I begin to increase, look at this. Now I'm recording an appreciable value, and that value now is being converted into the digital value, and that is the one that now is being passed as a delay function. You can see now. Okay, and if I continue increasing, let's say that the delay, once it comes back, because it has to loop through and come back. So let's say that we give the highest possible value. We expect that the delay to be a bit slower. You can see it's taking a bit of some time before it passes on to the next. That could be a lot of time, right? Let's just wait. You can see that. Then another one. Then a bit of some time. Then the other one will pick up. You can see that. And you can see that. You can wait again for some time. You can see that. It picks up. So you can see here the delay has become a bit slower. So the more values of analog value that I give into to be converted into a digital value, the longer the delay. So if I bring it a bit down, you can see here the behavior here will be different after a cycle has been done. So it hasn't yet come back. It's yet to finish the actual for loop. So it will finish its for loop first. The only last memorable value was the one that was there. So it has to finish the for loop. It has to finish, it has to go and then come back before now it loops back to change to a faster mode. That's to finish the scanning cycle. Now, since we've reached the end, we should come back in a slow manner to the same. That is it. So we have to wait till it comes back before it changes to a bit faster mode, because it has to do one scanning cycle before it loops now, before it moves out of the for loops to start from into the void loop. Now you can see here that now it has finished, so we expect it to be a bit faster now because we've reduced the time delay. You can see that it's a bit faster. It's not as slower as it was. Yeah, so we've made it to be, and it's a bit faster. It's not as slow as it was previously. Yeah, so you can see for yourselves that we've made it actually interactive. Okay, that's the beauty about all of this. So now, guys, I'd like to really thank you for viewing. However, the code, you can see it here. This is the code for the digital val interactive, which is pretty much the same as the code with the 65 millisecond delay, which actually didn't open, except that now here with a 65 milliseconds delay, what we just did, is the same code, but we write the delay, we had coded as 65. So wherever we have, we write as 65. But the code is actually the same code. Okay, so we had to first, just to summarize everything. So above the void setup, you had to initialize the variables. Now, what are these? The arrays and the float values for the analog voltage. Then here, what you did is that you had to set up. In other words, you had to initialize, because the void setup is used for initial as a point of initialization. Then once you did that, you had to come back and then give logic to your program. This is where you gave the logic. Where is the logic? So the logic was given here. You had to give logic to your program, and this is where you now gave logic to the programming. This is where you gave the logic to the program, and for sure this is how the program runs. So guys, I'd like to thank you really so much for viewing, and we'll see you in the next tutorial class lessons. Thank you.